Assalamualaikum warahmatullahi wabarakatuh. My name is Ilyas Aminuddin, class TA 20B. Title: Microcontroller Based Dual Excitation Tracker System for Maximum Solar Energy Generation. Abstract: Solar energy is becoming a promising renewable energy technology. Conventional fixed solar panels with a curtain angle limit that are often exposed to rotation of Earth. The automatic solar tracking system solves this problem. In this paper, a dual-axis solar tracker is designed and implemented to track the sun in both azimuth and altitude axis B using an AVR microcontroller. The implemented system consists mainly of the Atmega 328 controller, DC motor, leak sensor, and relays. The result shows that the design low-cost sun tracker increased the output power generation efficiency by 25 to 20% as compared with the fixed panel system. The effect of temperature and panel covering the colored colorblind on the performance of the designated system is also studied. The temperature and the colored colorblind decrease the output power of the solar panel. Keyword: Dual Axis Sun Tracker at Mega 320 NIC in 28 microcontroller photovoltaic solar energy maximum power point. Introduction: Energy is an essential factor for the development of nations. Most of the energy production depends on fossil fuels. The sources of the fossil fuels are limited. Therefore, there is growing demand on energy from renewable sources as solar, geothermal, and ocean tidal. Solar energy is more popular than other renewable energy resources to take over the scarcity of hydrocarbon in future. Photovoltaic PV panel converts the sun radiation to electricity. Maximizing output power from a solar system is desirable to increase efficiency in order to maximize the output power for solar panels. They must be kept aligned with the sun. As such, a means of tracking the sun is required. Solar tracker is a device that keeps photovoltaic or photothermal panel in a optimum position perpendicularly to the solar radiation during daily course. This can increase the amount of collected energy from the sun by up to 40%. Usually, fixed PV panel cannot follow the sun movement. The single-axis tracker follows the sun east-west movement, whereas the two-axis tracker follows the sun along a changing altitude angle too. Many tracker system technologies have been developed by my solar show a dual-axis solar tracker. Like this example picture, dual-axis solar tracker have more efficiency than both fixed-angle panel and single-axis solar tracker-based system. But this advantage is at the expense of more system complexity. The implementation of the Sun tracker system have gone by many workers. The performance of PV module is influenced by several parameters such as ambient temperature, humidity, rain, cold, and dust. In a desert environment, the operation performance is impeded. Variation, particles accumulation on surface and high ambient temperature. Therefore, in the paper, a dual-axis tracker system is designed and implemented. Its power generation performance is avoided and compared with fixed panel system under different temperature and cold operating station at the geographic area of Kirkuk City, Iraq. The profit system model is explained in section 2, together with the hardware and software design in patient detail. In section 3, the result of the practical test of the implemented system are given. Finally, concluding remark and the rest within in section 4. Methods: the progress rate tracking system track the sunlight be rotation the PV panel to different axes. The dual axis solar tracker for the angular height position of the sun in the sky. In addition, on following the sun is with movement. The proposed model of dual axis tracking is shown in like this example picture. The tracker model is composite of solar panel of 87 watt and is of very crystalline type for Koyocare company. In this leg is 100 while the weight is it is 5 centimeter for leak displacement resistant LDR sensor, 2 DC motor, Arduino Uno microcontroller and 4 relay. 2 LDR sensor and on motor with 2 relay are used to track the sun is with movement. The other 2 sensor and the other motor is fixed at the bottom of the tracker with the auto relays are used to track the sun's up-down movement. The DC motor are basically performing function of sun tracking. Upper panel hold the DC motor track the sun up-down movement and base DC motor track the east-west movement of the sun. This DC motor and sensor are effective in interface with a microcontroller which is controlling DC motor on the basis of sensor input. The LDR sensor sends the leg intensity and sends signal to the rotation direction of the DC motor according the stored program. The designed system is described in detail in brief. So the block diagram of the tracking system and the flowchart of the control program are given. This is an example of circuit image. This is a series of LDR algorithm algorithm. Start with taking data from LDR sensor. The microcontroller read this data and made a comparison between the and the decides about the movement direction of the DC motor. The electronic circuit in shown in this is a sample of circuit image. Result: two panels were tested. One of them was fitted on the implemented tracking system, where the position of the other was fixed at the local altitude 35 degrees of Kirkuk or Iraq. The test was done at May 2016. The generalized output current, the voltage were measured during at local time of group from 9 a.m. to 4 p.m. Illustrated the change of the out power of solar panel. With is the product is the circuit current ESG and open circuit for FUG with the local time of the measurement direction. So a grab single compression of from the fixed panel, single and dual axis tracker output power. So that for the fixed panel the power increases gradually and become maximum at 11 12 p.m. Then decrease with sunset. Will form the single axis tracker. The curve of the output power is high above the fixed PV array system and the gain is 24.0.5%. The used single axis tracker is the same implemented dual axis tracker but operated in the east-west direction only and the up-down direction is fixed at 25 degrees. Flexion angle and dual axis equals 26.22%. Peak power of compared to the fixed panel with is an agreement with the other works. Reform. There are many parameters with left included in the conversion opportunity of PC carry using tracker system such as temperature and illumination. So the effect of temperature has been investigated in this paper. So a plot of the output power versus time and monthly effort for the panel temperature versus time for the track panel and the fixed panel in May 2016 show that when the temperature of the panel increases, the output power of the panel decreases. Before finally, the effect of the panel covering the colored colorblindness on the output power of the tracker system is studied. The color of the cover is yellow, green and blue. The output from this colored colorblind is compared with the output of the solar tracker panel without any color as shown in this colored complaint is available in the market and cheap. From it can be concluded the colored filters only allowed lack of the some color to pass through. through. After analyzing the data, it was determined that the output of The panel under sunlight under was significantly thicker than any of the other colored light. This is due to the loss of light intensity inherent to the tint of the colored filter. Discussion on the microcontroller-based dual-axis tracking system for maximum solar energy generation is an innovation work to maximize the absorption of sunlight to be more effective when there may be several houses that are exposed to more sunlight, but solar energy only stay in one direction of the sun. But there are some problems in the assembly, starting from the sensor with mass width. The coding diagram must also be appropriate. Look at the power of the driving motor and is recommended to use cable without a connection. Everything must be carefully considered. Conclusions. In the paper, we have come to a con- conclusion that while axis solar tracker is more efficient in terms of the electrical energy output when compared to the single axis tracker and fixed solar panel. The gain of the dual axis tracking system is about 25 to 30% compared compared with the fixed system. For the temperature and converse, they they decrease the output power of the solar panel. Therefore, any conversion such as dust protection converse will have a negative effect on the amount of power generated in the solar panel. References number one, Nirmal, Heibi, and Nefet as a microcontroller-based automatic solar power tracking system. Number two, Sin, PE, and PO, VA dual-axis solar tracking control system be using microcontroller. Number three, Patori, GFT, E, and Suryavanshi is design and development of bidirectional bidirectional solar tracking system implemented in western region of Maharashtra. Number 4, Francisco de Pedro D. G. and Louis C. G. to axis solar tracker based on solar maps. Control B allow power microcontroller. Number 5, Abdul Latif K. E. A low-cost single-axis sun tracker system using big microcontroller. Number 6, Sharma M. An efficient low-cost solar tracker using microcontroller. Number 7, Gesul M. Design of an automatic solar tracking system to maximize energy extraction. Number 8, Madhu P. N. Viswendi V. Design of real-time embedded solar tracking system, International Journal of Energy, that in engineering research, or EJTIR. Number 9. Xie Yun El Poching Xi Jinping Xi and Xunfeng El Shun Tracking System. Number 10. Ghost as an Helder and Solar Tracking System using. Number 11. Will Wahel Air Force U B and C K study on dual axis solar sun tracking using microcontroller. Wassalamualaikum warahmatullahi wabarakatuh.